Hello, today we are going to look at a very interesting number theory problem in the GMAT 700 plus range. This is interesting because it draws upon two interesting concepts, bases and factorials. Without much ado, let me delve right into the problem. The question reads as follows. How many trailing zeros will be present in the base 12 representation of 55 factorial? Take a minute to read the question again and to absorb the information. How many trailing zeros will be present in the base 12 representation of 55 factorial? Good. So the trick in approaching such complexly formulated questions is to rephrase it in something simpler that you could work with. The question is at the end of the day asking us, what is the highest power of 12 that divides 55 factorial? So whenever you divide a number by any other number and it's completely divisible, the remainder is always a 0. So when this 0 is actually the trailing 0 that will be present when we divide one number, that is 55 factorial, by 12 successively. We know that 55 factorial could be written as 55 equals 55 times 54 times ... till 1. It's a very large number that we can't really multiply in the given time frame or whatever reason. So we will just take the number that we could work with, that would be 55. The second number that we could use would be 12. It's still a bit larger than what we would like to work with, so we will decompose 12 into its prime factors. So 12 could be written as 4 times 3, which in turn could be written as 2 times 2 times 3, or to consolidate 2 power 2 times 3. So the prime factors of 12 are 2 and 3. So any number that's a multiple of 2 power 2 will be a multiple of 12. Sorry, any number that's a multiple of 12 would also be a multiple of 2 power 2. Similarly, any number that's a multiple of 12 would be a multiple of 3. So any number that's a multiple of 2 power 2 times 3 would be a multiple of 12. So what we want to do is to find the highest power of 2 that completely divides 55 factorial, and similarly the highest power of 3 that completely divides 55 factorial. So let us figure out these numbers, starting with the smallest of the two numbers, namely 2. The way we do it is by taking 55 and successively dividing this number by 2 and aggregating the quotients, adding them up together to find out the highest power of 2. So 55 could be written as 2 times 27 plus 1. So 27 is the quotient, the number we are interested in. So we'll take it here. We need to successively divide 27. That would be 2 times 13 plus 1. Again 13 here. Six would be 2 times 3. Perfect. So that would be 3. So we got all the quotients from successive division of 55 by 2. So these are the numbers we are interested in. The highest power of 2 that would completely divide 55 would be the sum of all these quotients. That would be 27 plus 13 would be 40 plus 6. 46 plus 3 is 49 plus 1, 50. The highest power of 2 that completely divides 55 factorial would be 50. But what we are interested in is highest power of 4, because 12 is 4 times 3 and it has 2 power 2. So the highest power of 4 that completely divides 55 factorial would be half of this. So this is the number we are interested in. So we'll make a sign out of it. So highest power of 4 would be 25. We have one number, but what we don't know is the highest power of 3 that could completely divide 55 factorial. This number could be greater than 25 or lesser than 25, something which we don't know. But intuitively we know that this number would be greater than 25 because 4 is a bigger number than 3. But let's check it out. It takes half a minute and we could do it to ensure that we are on the right track. So, taking 3 here, 55 could be written as 3 times 18, that would be 54 plus 1. As we did before, let's move 18 to the side. 18 could be written as 3 times 6 plus 0, perfect. So take 6 here, 6 would be 3 times 2 plus 0, so we take 2. 2 is smaller than 3, so we leave it at that. So the highest power of 3 we are looking for is 18 plus 6 would be 24 plus 2, 26. As we intuitively thought, so 26 is bigger than 25 because 3 is a smaller number than 4. So the highest power of 3 that we are interested in is 26. Because in 12 we have 4 times 3 because 3 power 1. We don't have to divide 26 by anything else. So with that we have two numbers that we are interested in. So now to find out the highest power of 4 that completely divides 55 factorial, we could write 2 power x, where x is the number we are looking for, that completely divides 55 factorial. So 12 we know that 4 times 3, and we know that 4 power 25 completely divides 55 factorial. Similarly 3 power 26 completely divides 55 factorial. The product of these two numbers also completely divides 55 factorial. So what we are interested in, the highest power of 12 completely divides 55 factorial. So this is what we have. So we could rewrite it as 4 power 25 times 3 power 25 times 3. What we have done is we have taken 1 3 out and made it common superscript exponent. In the law of exponents we know that two numbers have the same exponents, we could aggregate them together. So this becomes 4 times 3 power 25 times 3. So multiplying within the braces, 12 power 25 times 3. So 25, the number we are interested in. So the highest power of 12 that completely divides 55 factorial would be 25. This is the answer. So 55 factorial when divided by 12 successively will result in 25 trailing zeros. So this is how you solve such a problem. I hope you enjoyed this video. I would like to hear your feedback.